morning, afternoon, or evening. How y'all doing today? Welcome back to Morrow's Math Quarter. Today we're going to continue with radicals and we're going to learn how to work with rational exponents and how to simplify radical expressions. So let's get right to it. You can write a radical expression in an equivalent form using fractional or rational exponents instead of a radical sign. How do we do that? In general, the nth root of x equals x to the 1 over n power for any positive integer n. Like the radical form, the exponent form indicates the principal root. How is this working? Well, if you notice here, the exponent of x is an invisible 1. Sorry about that. That should have been like this. And the way we go from radical form to exponential rational form, it's going to be the exponent variable over the index. What is this man talking about? Let's check this out. Square root of 36. 36 has an exponent of 1. There's an index invisible here of 2. So this is 36 to the 1/2. 1 is the exponent of the radicand. And the 2 here is the index. It's that simple. The cube root of 64. Please note that 64 has an exponent of 1. So this is 64 to the 1/3 power. 4th root of 16 is going to be 16 to the 1/4 power. Please note that there is an invisible 1 there as an exponent. So to go from radical to rational exponent form, it's the radicand raised to the exponent over the index. So once again, let's get some rules here. So when I have x to the 1 over n, that relates to the nth root of x to the first power. The denominator is the index, and the numerator is the exponent of the radicand. When I have x to the m over n, once again, the denominator is the index, and this time, or not this time, the same thing, the numerator is the exponent of the variable inside the radicand. This can also be written as the nth root raised to the m power. Okay? And then when I have, just like before, a negative exponent, even if it's a negative rational exponent, if I have it in the numerator, I'm going to go ahead and bring it down to the denominator to make the exponent positive. And then from there, I have my n, my denominator is the index, and my m, as in Mary, is the exponent. Okay, let's put this to work here. Convert each to radical form. We have here the 7th root of x to the 3rd power. Is that simple? Over here we have w to the negative 5/8. So that's going to be 1 over w to the 5/8, which will equal 1 over the 8th root of w to the 5th power. I have w to the 0.2. Please remember that that's simply just w to the 1/5 power, which equals the 5th root of w to the 1st power, or you could write it as the 5th root of w. Either of those are valid. Okay, let's continue. Remember once again, x to the 1 over n equals the nth root of x to the 1st power. X to the m over n is the nth root of x to the m power, or the nth power of x raised to the m power. And x to the negative mn power becomes 1 over x to the mn power, which equals 1 over the nth root of x to the m power. Let's convert each. So I have the square root of a to the 5th power, so this is going to be a to the 5 over 2. Remember, there's an invisible root of 2 here. The 5th root of b raised to the 3rd power, this is going to be b to the 3/5 power. The 4th root of x cubed, this is x to the 3/4 power. It's just a matter of learning the formula. Okay, let's go ahead and simplify these now, each value. Okay, you don't need a calculator for this. You can use one, but you don't need it. 2.5 rather is the same thing as 5/2. So I have 16 to the 5/2. That means I have the square root of 16 to the 5th power. Now, check this out, y'all. This is the beauty of knowing your powers and your perfect squares. The square root of 16 is 4. All right? So if the square root of 16 is 4, don't I have 5 16s though? So if the square root of 16 to the 5th would be, in essence, 4 to the 5th power. Does that make sense? So that would actually equal 1024. Whoa, what did you do here, Moto? The square root of 16 is 4, but there's 5 of them, so 4 to the 5th power is 1024. How about 32 to the negative 3/5 power? That's going to equal 1 over 32 to the 3/5 power, which is going to equal 1 over the 5th root of 32 cubed. Now, the 5th root of 32 is 6. But there's 3 of these 32s in this 5th root. So if the 5th root of 32 and I'm sorry, it's not 6. The 5th root of 32 is 2. And 2 cubed is 8. So this would become 1 over 8. Again, why? The 5th root of 32 is 2. 2 cubed is 8. How about 8x to the 15th raised to the 1/3 power? Let's go ahead and distribute. Because remember, whenever you raise a power to a power, you go ahead and multiply those powers. So this is going to become 8 to the 1/3, x to the 5th, which is going to be the cube root of 8 times x to the 5th. And the cube root of 8 is 2, so that's 2x to the 5th. Pretty simple. 16y to the negative 8 raised to the negative 3/4. Remember, we're going to, whenever you raise a power to a power, you're going to distribute that power. So this is 16 in parentheses to the negative 3/4 times y. Negative 8 times negative 3/4 is going to be 24 over 4, which is y to the 6th. This is then going to equal y to the 6th over 16 to the 3/4. This will then equal y to the 6th over the 4th root of 16 cubed. The 4th root of 16 is 2. 2 cubed is 8. So this is y to the 6th over 8. Not that bad, is it? Got 9x 4th root of y raised to the 3/2. Remember that you're going to, when you raise a power to a power, you're going to distribute that power to everything here. But Moto, I have a 4th root, not a power. So the first thing we're going to do is convert that 4th root to y to the 1/4. And now we're going to raise it to the 3/2. So that will be 9 to the 3/2 times x to the 3/2 times y to the 3/8, which will equal the square root of 9 cubed times the square root of x cubed times the 8th root of y cubed. The square root of 9 is 3. Cubed is 27. 3 goes into, or rather 2, the index of 2 goes into 3 one time with 1x left over. And then I cannot take any y's out of this 8th root. So my final answer will be 27x times the square root of x times the 8th root of y cubed. Now, dealing with rational exponents is easy as long as you remember the following rules. Remember our power rules. A to the 0 power equals 1. Anything to the 0 equals 1. When I multiply the same bases, I keep the base and add the exponents. When I have a negative exponent in the numerator, I bring it down to the denominator to make that exponent positive. When I divide the same base, I keep the base and subtract the exponents. When I raise a power to a power, I distribute the outside exponent to all the exponents inside the parentheses. When I have a negative exponent in the denominator, I bring it up to the numerator to make it positive exponent. If I have a fraction raised to a power, I'm going to go ahead and distribute that power to every single exponent inside of the parentheses. If I have a fraction raised to a negative exponent, I can go ahead and reciprocate the inside of the parentheses and change that exponent to a positive. And whenever I raise a power to a power, remember that I'm going to keep the base and multiply the exponents. So, how would I do this? 27 to the half times 27 to the 5/6. Please don't make a mountain out of a molehill here. I'm multiplying the same base. So this is simply 27 to the 1/2 plus 5/6. This goes to 6, that goes to 3, so that's 27 to the 8/6, which I can reduce. So that's 27 to the 4/3, which equals the cube root of 27 to the 4th power. And the cube root of 27 is 3, and 3 to the 4th power is 81. Let's go. 8 to the 1/3 divided by 8 to the 5/3. Whenever you divide the same base, you keep the base and subtract the exponents. So that will equal 8 to the negative 4/3, which is going to equal 1 over 8 to the positive 4/3, which equals 1 over the cube root of 8 to the 4th power. And then the cube root of 8 is 2. 2 to the 4th power is 2, 4, 8, 16. And you have 1/16. Let's go. 36 to the 2/5 raised to the 5/4. Whenever you raise a power to a power, you multiply the exponents. So this is going to be 36 to the 10/20, which is 1/2. And that is the square root of 36, which equals 6. Whenever I raise a power to a power, I distribute the outside exponent. So 1/2 times 3/2, that's x to the 3/4. Y to the 2/3 times 3/2 is just y to the 1st power. And we are done. Okay, we got to do a couple things here. First, we're going to go ahead and add the exponents up here, because when you multiply the same base, you keep the base and add the exponents. So this goes to 6, that goes to 3, that goes to 6, that goes to 2. So that's x to the 5/6 divided by, when you raise a power to a power, you distribute. So that's x to the 2/12, which is 1/6. Then when you divide the same base, you keep the base and subtract the exponents. So that's x to the 4/6, which is x to the 2/3 in exponential form, or the cube root of x squared in radical form. How do you want us to do it, Mr. Model? It really depends on what I'm asking. So you got to know both ways, please. Okay, I've got x to the 2/3 times y to the negative 1 times x to the negative first power, y to the 1/2 raised to the 2/3. First things first, order of operations. I'm going to have to distribute that outside exponent. So this is x to the 2/3, y to the negative 1 times x to the negative 2/3, y to the 1/3. Now I'm going to multiply. So when I multiply the same base, I keep the base and add the exponents. X to the 2/3 times x to the negative 2/3 is x to the 0, which is just 1, times y to the negative 1 times y to the 3rd to the 1/3. When you multiply the same base, you add the exponents. That goes to 3, that goes to negative 3. So that's y to the negative 2/3, which will equal 1 over y to the 2/3, or 1 over the cube root of y squared. Once again, please, you must be able to write it both in exponential and radical form. Okay. We've seen this before. When it's real ugly inside, go ahead and simplify the inside first. Okay? So this is going to be a 9. Then I have x to the 1 minus 5/6. And then I've got y to the 4/3 minus a negative 2/3. Please make sure all of those operations are clean. So this is going to be 9. X to the, this becomes 6 over 6, so x to the 1/6. And this becomes a big plus, so that's 4/3 plus 2/3 is 6/3, which is 2. So y squared to the 1/2. So this is 9 to the 1/2, x to the 1/12, and y to the first power, which equals 3 x to the 1/12 y, or 3y times the 12th root, sorry, not 13th, but 12th root of x. So once again, please be able to put it into both exponential and radical forms. Okay, I've got 8 times 125, a to the 3/4, b to the negative 1 raised to the 2/3 power. I'm going to first distribute that exponent to every single exponent on the inside, giving me 8 times 125 to the 2/3. A to the 3/4 times 2/3 is going to be 1/2. And b to the negative 2/3. Next step, I'm going to go ahead and make this exponent positive. So this was going to become 8 times the cube root of 125 squared, a to the 1/2, over b to the 2/3, which will then give me 8 times the cube root of 125 is 5. 5 squared is 25. A to the 1/2 over b to the 2/3. 25 times 8 is 200. A to the 1/2 over b to the 2/3. Or, if I want it in radical form, 200 times the square root of a over the cube root of b squared. Please remember, you must be able to write it in exponential and radical form. Okay, we're almost done. See what we got here. We've got the 8th root of 16 to the 4th power. Me personally, I'm going to rewrite this as 16 to the 4/8, which is 16 to the 1/2, which is the square root of 16, which equals 4, makes my life a lot easier. I'm going to go ahead and convert this to x to the 1/2 over x to the 2/3. And then I'm going to remember that whenever I divide the same base, I keep the base and subtract the exponents. So that goes to 6, that goes to 3, that goes to 6, that goes to 4. So that's x to the negative 1/6, which equals 1 over x to the 1/6, which equals 1 over the 6th root of x. In this case, we either have it in exponential or in radical forms. As always, got to have those skills for both. Okay, cube root of 64, you should know that one already. That's 4. Cube root of x to the 6th power. 6 divided by 3 is 2 with no leftovers. And the cube root of y cubed, 3 divided by 3 is 1 with no leftovers. D, the square root of the cube root of y. Well, the square root can be rewritten as 1/2. And then the cube root can be rewritten as 1/3. And when you raise a power to a power, you multiply the exponents, giving me y to the 1/6 or the 6th root of y. Once again, giving me both exponential and radical forms. The 10th root of 36 to the 5th power, don't stress that. If you can go ahead and rewrite this as an exponential, you can reduce fractions. So that becomes 36 to the 1/2, which is the square root of 36, which equals 6. The 4th root of 16, x to the 8, y to the 12. The 4th root of 16 is 2. How do you know that, Moro? Well, if I break down the 16 here, I got 2 times 8, and then 2 times 4, and then a 2 and a 2. Remember that the index tells you how many of the same value you need to pull one of those values out. So I got a 2, a 2, a 2, and a 2 that comes out as a 2. The 4th root of x to the 8th, you divide the exponent by the index, that's 2. And the 4th root of y to the 12th, you divide the exponent by the index, which is y cubed. And you are done. And last but not least, let's put our thinking caps on here. Don't be afraid of this. Write an expression containing rational exponents as a single product. They have here 9x to the 4/3 plus 4x to the 1/3 times 3x plus 5. They want you to simplify that by factoring out x to the 1/3. If you remember, factoring a common factor means that I'm dividing that value out of every term. So when I'm factoring this out, when I'm factoring out an x to the 1/3, I'm literally dividing by x to the 1/3 to all of these terms here. Remember, these guys are prisoners, so they don't get affected. So now, 9 times x to the 4/3 divided by x to the 1/3 is simply going to be 9 x to the 4/3 minus 1/3, which is 3/3, which is 1. Plus 4x to the 1/3 divided by x to the 1/3 is simply a 4. And I have a 3x plus 5 left, which then will give me 9x plus 12x plus 20, which gives me 21x plus 20. Don't be afraid. You've got the skills. Try one more. Simplify 8x to the 3/2 plus 3x to the 1/2 times 4x plus 3 by factoring out an x to the 1/2. Factoring out means I'm going to be dividing that value, that monomial, to everything here. So 8x to the 3 halves divided by x to the 1 half is 8x to the 2 halves, which is 8x. 3x to the 1 half divided by x to the 1 half is a 3. And I'm left with this 4x plus 3, which I distribute. 8x plus 12x plus 9. And that gives me 20x plus 9. And there you have it. I know it was a lot of information, but I know you got it. Thank you so much for watching. Come back anytime. Take care now. Bye-bye.